Okay, let's go. Okay. Guys, my name is Jeff Campbell. I'm with Power and Process, and today we're going to go do owner's training on the PK compact water heater. This particular unit here is a PK10, very similar to what you guys already have in the facility, just a little bit larger unit. I'm going to go over basic operation of the unit. We'll go over the safeties, and then we'll go over troubleshooting, and if you guys have any questions. Okay, basic operation. This unit is a semi-instantaneous water heater. It has a U-tube bundle, which goes from front to back. These tubes inside here start in the front, they go up, turn towards the back. There's a baffle in here that divides the bundle itself. So as steam enters, it goes up the U-tube bundle, gives off its energy, it condenses on the back side, which is where your condensate connection is back here, and then out through the trap. The bundle is designed with staggered baffles. You have your cold water inlet, you have baffles that are 3/4 of the way staggered like this, all the way up the bundle, so as the water travels through, it has to make its way all the way through the bundle, which makes it very, very efficient, okay? We can provide you cut sheets, absolutely. At the top of the bundle goes to just about below this box, the U-tube. Just below the sensor port, there's a plate with a notch. It's a rectangular notch which forces the water directly across that sensing bulb. So as there's a demand for hot water, everything is pulled directly across that bulb, and it can sense temperature change like that. So these are designed basically to be about plus or minus 8 degrees from set point, and these are set to do 140. So you may see under heavy demand it may go down to 132, 133, and as it comes up it may go 145 or so, somewhere in there. Yeah.
Do all of the sensing bulbs work that way? 8 degree differential?
Roughly, yeah. Okay. I mean, that's what they, a 40 to 140 temperature, so inlet water coming in at 40, going to 140, that's how they size it. Okay. That's how they control. When you have recirc water coming back, it helps because your inlet water is now 80, 90, 100 degrees versus 40 degrees, so that definitely helps balance it out. This is very crucial to the semi-instantaneous part of the way this unit operates. This keeps any cool slugs from developing in the shell, constantly keeps the water moving in the bundle, so that when there is a draw, you don't have 3-4 gallons of 10 degree less water here, and then it hits the sensing bulb and this thing's going to go crazy. If this fails, first thing is you're going to notice erratic temperature. If you have erratic temperature where it's swinging a lot more or getting to the point where it's lifting your relief, this is the first guy you want to look at, okay? And you don't want to verify that it's just spinning on the shaft. I've seen them where the actual impeller breaks off or it just disintegrates and turns to nothing. You guys have seen it a million times, I'm sure. So you actually have to pull it out, make sure that everything's intact, and make sure that that's good to go. These usually last a pretty long time. They changed these to a bronze pump. These are called the Bronze Fox, B&G makes. They're pretty durable. Haven't had too many issues since they changed over from the old style with the coupling and the clutch and the whole setup there. So we're going to go over safeties real quick. There's 4 safeties on this unit. I'm going to open up the panel up here so you guys can have a quick look. Inside this panel you have an aquastat right here, which is set to 20 degrees above your temperature set point. These are set to 140 degrees, so that's at about 160. 160, 165, somewhere in there.
Change them up, huh?
Yeah, this is Jumo. They used to use the Honeywell, but now they use the Jumo.
How's that?
Those are fine.
Okay.
The only thing I don't like about them is the numbers are really small, so if your eyes are, kind of, you got to squint to see them. But each line represents 10 degrees. So now this aquastat controls 2 of the safety solenoids. You have your steam shut-off solenoid, and you have your hot water dump over temp solenoid. So we have this set for 160.
And what? That's that one there?
That's that one there, yep. That's an ASCO 1/2 inch. It's always good to have a couple of spares. I can give you guys the number. Okay, it's a JKF 8210 G002HW. I just forgot somebody's birthday, but. So yeah, always good to have a couple of spares on those and these as well. So what happens is, if you have a temperature issue, let's say your pump fails, your temperature starts to swing, you start to lift your relief, this light comes on, you start dumping hot water. Both of these solenoids are normally closed solenoids. When you power up, this opens, power to open. That stays closed. If you over temp, that aquastat will send the power from here to there, closing the steam solenoid, which will allow the valve to shut and kill steam to the unit, and then also open that to dump the hot water until we get back down to temp. And that will come back, when this clears 10 degrees below, it will come back on and then try to run again. And a lot of times they just go back and forth, and if you have an issue, it's got to be rectified. Exactly, exactly. The other safeties we have on this, up top it's a little difficult to see. We can actually see it on this one a little bit better. You've got a temperature and pressure relief valve, which is 150 psi or 210 degrees Fahrenheit. That will lift. That's a backup to this. If this fails.
So that's your back. That's what's different on these is that also that's got a backup.
Yeah, this backs up that. And now we have a backup to the pressure side of the T&P relief valve, which is this guy right here. This is a pressure-only relief valve. This will lift at 150 psi. And that is a backup to the temperature and pressure relief valve up top.
That's only pressure.
Pressure only.
Question, what's up with this handle on here?
That's something that, because there's a gear in here.
So you can adjust
This is a pin. I don't know, this is when they put them together at the factory, I think they turn them to a certain point and then they set it. They have this lock, there's a pin in here and a gear. So you really don't have to concern yourself with any of that. It's just yeah.
It looked like a ball valve, like you were able to shut
Yeah,
it off, you know?
yeah.
That's your adjustment point, okay.
I haven't had one fail yet. They've been using them about 3 or 4 years now. It's ASME, that's why they had
Who's
it.
the manufacturer?
This particular one here is Apollo. Apollo, yep. Okay, so what I'm going to do, we covered the safeties. I'm going to go over general operation of how this thing actually opens and closes and works.
Can I ask you one quick question?
Sure.
What's supposed to go inside this port? Temperature sensor or something?
That there?
Yeah.
That's a vacuum breaker. I'll go over that.
Oh, okay.
Yeah. They actually started installing these because we've been telling them that we want them on there. Trying to give them feedback from the field. And this helps you get a nice tighter control because, well, I'll go over the operation and we'll cover that as I go because that's part of it.
No,
all right?
it looks like this could have been like a...
Yeah, no, that's actually just a vacuum break. Yep.
It's like a gauge goes.
Yeah.
Well, yeah.
Okay, so yeah, and there's no well on that. That goes directly into the bundle. Okay, so we have here what's called a T14 pilot. This is a temperature pilot only. It does not adjust pressure, okay? 3-inch Spence main valve. You have your what's called thermal assembly or your thermostat, which is this guy right here, and your sensing bulb that ties into the side of the unit. Okay, this particular unit has a 704 bulb. They have longer bulbs, 700s. I'm sure you guys have seen. This is a 704 bulb. There is not a well there's no well there. That's direct in the flow of the water. Okay.
Is that a Spence bulb or is that a PK
Yes.
bulb?
Spence. This is all Spence. Yes.
No, I know, but
Yep.
I'm talking about the bulb there. That's not
yeah.
your bulb.
No, that's Spence.
Okay.
Yep. So this is charged with ethyl chloride, which is a chemical compound, and it expands and contracts when it's heated and cooled. So as there's a draw for hot water demand, somebody opens up a couple sinks or they're taking showers and there's a draw. Water passes through the bundle, it goes across the bulb. The bulb's going to sense that temperature change. Excuse me. And as this notices that cooler temperature, it's going to contract, which is going to allow whatever spring tension you have dialed up on this pilot, it's going to allow this pilot to lift open. As the pilot lifts open, steam enters through this T. This is what we call the bends and fittings on the Spence valve. This is just an open T, there's no orifices in here. As steam enters into these lines, the pressure starts to build. There is a small hole right here inside this fitting. On this particular valve, it's 3/32 of an inch. Okay, this one here. Steam will start to go through that hole. but it can only bleed off so much, and it will start to build pressure and send pressure down to the bottom of the valve. The bottom connection on the valve just has a brass 90-degree elbow, and that has a small orifice in it. We call it a restriction elbow. The reason that restrictor is there is to give you smooth operation of the valve, so it opens nice and slow and closes nice and slow. It gives you good control, you're not going to overshoot, and the valve's not going to slam shut and hammer the seat and disc. So what happens is, as steam enters here, you have condensate developed underneath the bottom of this valve. If you ever notice your Spence valves throughout the facility, they'll only be insulated to this line right here. The bottom of this valve needs to be exposed to atmosphere. This needs to be able to condense because that's how it operates. So you basically have condensate underneath here to this point, right across to about here. So this is all condensate. I get this question a lot. Well, I took the line off and I got a bunch of water out of there. Well, that's a good thing. You're supposed to. You're supposed to have condensate in there. So as steam enters, it hits that condensate and it starts to push the condensate through that small orifice in the 90, which allows the valve to open. As the valve opens, it puts steam into the unit. It heats up the water. Whatever tension you have on this spring, right now we have these set to 140. So on these pilots, up is up for temperature and down is down. But counterclockwise brings it up. So as you put more tension on this spring, you're going to need more hot water to force it closed. It's an easy way to think about it, but up is up, down is down. So counterclockwise will actually put more tension on this. And that's it. As far as adjustments, that's it. There's no pressure, no anything. That's just a temperature only adjustment. Once this is satisfied and that gets hot enough to where it drives this closed, the pilot shuts. The steam that's developed, the pressure that's in these lines needs somewhere to go. If that pressure is trapped in here, it's going to keep the valve open. It's going to keep feeding steam to the heater when you don't want it, and you're going to have an overtemp situation. So what happens is that small orifice, which is called the bleed port, which is right in this fitting, if that becomes clogged with any kind of debris, it will trap the pressure in these lines, keeping pressure on the bottom of the valve and causing an overtemp situation. When it's free and clear and operating properly, the pressure that's in here will just bleed through that hole into the downstream side of the valve, and the valve will be allowed to close. So on an overtemp situation, the first two things you want to look at are your pump and that fitting. The fitting is always the easier one to check. You can shut it down, you can kill your steam. Go ahead and take that line off. Once you shut the power, you're going to kill this solenoid. So you're not going to have any steam entering here. But if you have an issue with the valve not holding, you may have pressure, so it's always good to shut the main line down before you check that. 330 seconds, drill bit, clean it out. Do not make the hole any bigger. It's that size for this particular valve. So if you take it out and you go to drill it and you use a bigger bit, it's going to affect the performance of the heater and the valve. Okay.
What I brought those tip cleaners in for, Gary.
Yeah.
I had to do the ones in the center base or the SCP.
Yeah.
And it works perfect.
Yep.
Put it in 2 seconds.
The vacuum breaker, we'll get to that next. As steam enters and it condenses, it will pull a vacuum. If steam is allowed to sit there and pull a vacuum, it will hold its BTUs and it will still give off heat. And you'll notice a little bit more of a swing. As the steam tries to condense in the bonnet, it will release that vacuum and it'll allow atmospheric air in to break that and cool it, so to speak, and that'll also give you a tighter control. You're not going to get a little, if this is just sitting there and there's no draw, but that's still giving off heat, you're going to see a little bit of rise in temp. So that helps to control that a lot, and that's something we've made a push for with PK, and now they come standard on there. Okay. As the steam condenses, it comes out the back, goes through your strainer, through your trap, and to your condensate receiver. Bundle replacement. PK has designed their pedestal so that this is big enough to remove the bundle out the bottom if this ever needs to be changed. You don't have to. You don't have to. You would never think it. It doesn't look like it.
What was that again? Repeat that.
Pull the bundle out.
This pedestal is designed so that this bundle will drop right out the bottom like this and come right out.
Wow.
Yeah, I've done a few,
Wow.
and it's impressive. And one
bundle
thing
doesn't
that's
go all the way to the top.
no, like I said, it right at the bottom of the panel is where it makes its turn and goes over. Now, these are double wall, but the single walls are the same. This here, this tube sheet is threaded. Now you can see where the studs go into the tube sheet right there. That tube sheet's threaded, and it's also threaded on the top. So when you go to remove the bundle, if you ever have one go bad, you can take these bolts off, pull these bolts off here, drop this down, break your union, drop this down. The tube sheet is going to, the bundle is going to be held in. It's not going to fall out all at once. It's not a.
Then you unbolt it from the top. And
then you unbolt your studs from the top, your nuts from the top. Those studs will stay, and then this drops down. It gets, you know, once this gets to here, it just about clears. You grab the bottom of it, you just kind of slide it towards you, and it comes right out. You know, you'll have few connections here. Yeah, if you get a bundle, it comes with a new gasket. You've got your water gasket, which is right here, and then you have your steam, which is here. The only gasket it doesn't come with is the one for your flange. You'd have to get that separate. The bundle comes with those two gaskets.
Chef, how often should you? I know there's a service where you flush this thing.
Yeah.
Well, you acid wash it too, right?
Yeah, we do. We use a biodegradable descaler called Ridline, and we introduce that into the shell, and we circulate it.
It's not piped, though, to clean where you can isolate the bundle actually,
Well,
the way they pipe them.
yeah.
Which no one ever pipes them to isolate where you're actually cleaning the coil.
Yeah, I mean, we can utilize the cold in, the hot out, the recirc. The one thing with using the Ridline is it has to be vented. You can't just pour it in and seal it up, and because it will foam a little bit. So what we do is we introduce it right there where the sensing bulb goes in, and I just use 1 1/4 inch Street 90 brass with a short nipple and a funnel, and I put it in there, because if I get my solution up to that point, I know my entire tube bundle is submerged, and then we utilize the pump to circulate it. Of course, we have to isolate everything else, the steam, the water, everything else, and then we do that for about an hour.
Now let me ask you this: how often should that be done?
I currently have several contracts. I do over 150 heaters yearly. Yale, Wesleyan, Mohegan Sun, a bunch of hospitals, Hartford Hospital, St. Francis Hospital. I've got a lot.
And
so
it's recommended to do.
yeah,
right?
it is recommended. Yeah, yearly service. We check the safeties. We go through everything. I'll do a diaphragm check on the valves, make sure that they're holding pressure. Yeah, I put about 20 pounds of pressure under here. These valves are for medium to high pressure. 15 and below, you guys have the valves where they have the longer hood, which have the high car, the rubber diaphragm. These are the larger valve with the 2 stainless steel diaphragms in the bottom that overlap each other. Yep. So we do a pressure check on that. We'll check all the safeties. We'll clean the orifices, run the Ridline through, make sure your pump is operational. Check operation of the trap. We'll shoot it with the temp gun. We'll blow down your strainer. Each unit, about 2 hours. Shut it down. It's an hour to run the Ridline through, and then another hour to do the other checks, rinse it, and bring it back online.
What do you guys get for cost on that?
I think it's $400 per unit. Don't quote me on that. I think it's in that neighborhood. As far as operation of the valve, these Spence valves, they're pretty durable. They're pretty rugged. The only thing that really goes bad is over time, you may have to change a set of diaphragms. And again, if it's properly sized and it's not constantly modulating and trying to keep up, they last a long time.
Do you guys stock Spence valve parts now?
We do not stock, but we still have access to them. We are now the Watson rep, Watson McDaniel. So it's something that we can get. I try to stock different size valve diaphragms, but we don't always have them. I try to stock the most common sizes, 1.5", 2 inch, 3 inch. Those are the most you're going to see. If you run into a 6-inch valve or something like that,
It'd be a good idea if, like, say for a hospital, just purchase just like one set of
I would
diaphragms.
recommend for the units. You have 6 of these. They're identical.
Right.
6 identical units. I would recommend the 1/4-inch shutoff solenoid, the overtemp solenoid, a set of diaphragms, and I wouldn't worry about this one too much because I haven't seen failures on these, but I'd keep a spare T&P as well.
Which is based on pressure anyway, right?
Pressure only.
Yeah.
Pressure only. Yep. And really that's it. You don't really need, you know, and a spare pump. I would have, you know, seeing since you guys have 6 units here, I would have a spare pump, a spare solenoid. It may not be a bad idea to carry a full T14 Pilot as well, being that you have 6 units here, to have one of each. You know.
Building, right?
Yeah.
Yes.
Not to mention the one.
Correct.
So the 8 over there, what is that? 18,
There's a few of them over there. Yeah, 1, 2, 3, at least 4 of that I can think of off the top of my head.
Same size, are those 8s or
They're probably different size valves, but they're gonna. This will be the same.
solenoid?
The solenoids will be the same. The pilots will be the same.
Yeah.
The only thing that'll be different is you'll have to order different size diaphragms for whatever valves you have in that
Jeff,
setup.
all 3 of them are running at this point, right?
Yes.
Now, say if one fails, do we have enough juice to carry the load with 2?
Absolutely.
Okay.
And that's a good point because that's something I wanted to touch on really quick. Well, when you go to ice, let's say you have a problem with one of these units and it's over temping and you need to troubleshoot it and figure out what's wrong. Shutting it off solely by the switch is not going to isolate it. We need to isolate the hot out, cold in, the recirc line, even the steam line. Because if you have something stuck in the valve and you shut that off, it's still going to feed steam if you don't isolate the steam line, even by shutting that and killing the solenoid. So it's always best to just completely isolate it, take it out of the loop, because what will happen is if this one's going crazy, let's say you're blowing off your T&P up top, that's going to affect the way that those 2 run because they're all piped to the same header. So if this one's dumping how many gallons a minute because it's over temping, these 2 got to keep up with that plus the demand of the building. So once you get the problem one isolated, those 2 will settle out and then you can focus on what the issue is here. So always want to just take it completely out of the
I
loop.
just want to make sure we have enough.
Yeah, there's plenty of redundancy here where 2 units will hold.
What do these three units serve?
Good question. I don't know. I'm assuming from here to the 3rd floor. I don't know actually what they serve, but I can get those answers for you. I can call John Hull from Grodsky.
Someone from Grodsky was going to be here too.
Okay. I wasn't sure of that.
Facilitate.
They
Yeah.
have a flood going on up on the 3rd floor.
They got a flood.
Oh, that way?
It is about blowing off up there. I don't know if it's still water. I don't know.
All right. Well, it's good they're experiencing instead of us at this point.
So
We're really supposed to have.
yeah, and even in a pinch, Frank, even in a pinch, worst case scenario, one of these units can hold a lot.
That's good to know.
That could probably, that certain unit there with that size valve could probably do 80 to 100 gallons a minute.
Jeff, say
Excuse me.
you are running just like one.
Yeah.
Should I increase the temperature to, or will it?
What I would do is
You
leave
know what I'm
it.
saying? To
I understand.
compensate
Let it just see what happens.
And then go
If
from
if
there.
you if you see it sagging a little bit, you could certainly dial this up.
Okay.
But what I recommend is, so you're not
what
guessing,
it does.
just mark it.
For, yeah.
You know, mark like, you know, wherever, put a black line here and put a black line here. Now, if you turn it that much, for the time being, now you know you got to turn it back to here
Right.
when everything's all set, just so you're not guessing and you know that that was correct from day one. You know, that's a good point too. If you have an issue with the heater, a lot of times, a lot of times guys will just, oh my God, and they'll just start going crazy with the settings. And this has been set up, it's been running for a long period of time, months, years, whatever the case may be. So chances are nobody came by and threw this out of whack. Right. So this is really the last thing you want to start messing with because this is set already.
Yeah.
So it's other things that you want to look at. The bleed port, the circ valve, things like that. One thing I wanted to touch on, we had talked about troubleshooting. When this hole becomes clogged, you have an overtemp issue because the pressure in the lines becomes trapped. The one down at the bottom, the elbow, has a much smaller hole.
Oh, really?
Much smaller. If that becomes clogged, you will have no hot water because the pressure can't get to the diaphragms to open the valve. So you'll have a situation where you come in here and you're sitting at 90 degrees and you don't know why. That's the first thing you want to check. Take that elbow out, make sure that that hole is clear. It's a much smaller hole. Usually you need like a piece of wire to clean it out. Okay, again, don't make it any bigger. It'll compromise the performance of the valve. But if you run into a situation where you come down here, you have no hot water, check that fitting. More often than not, that just became clogged with a little bit of debris. Something got in there and it got stuck.
Will happen.
It can happen. Normally, I see it more on systems where they shut down because they're using a different source of heat. They don't run their steam in the summertime, so they're using electric, and then they switch. When they sit for a while, they get crusted up
Better
and
off that
they need to be cleaned. These like to run. These don't like to be shut off and not, you know, and sit dormant. These like to run.
Now, these are set for 140.
Correct.
Are all the water heaters here set up at 140?
Yes.
Okay. So then we have a lot of mixing valves.
Correct. Yep.
Tempering the water.
Yeah, down to 120 or 115 or wherever it's feeding. I know, I don't see it here, but I know the ones up on the other floor. The actually it's right there. Okay. Yeah. Yeah, it's all 140 out of the units, and then tempered down to like 120 or 115 or whatever through the mixing valve and out.
Now that's for the reason of Legionella.
Yeah. And it's also you know, you can't rely on just the PKs to maintain 120 all the time. So bringing that up to 140, knowing that you're definitely supplying enough hot water to give you 120 when you're knocking it down. And these actually, these aren't a tank style heater, so you don't really have a good chance of Legionella's build, you know, a lot of the older tanks and stuff, that's something you had to concern yourself with and keep the tanks at 140, 150.
So really, if there was a hot water problem that we got a call for hot water, we
right.
wouldn't necessarily come. We want to check the heater, but we also want to check the mixing station.
Correct.
See what temperature we're going to the mixing station.
That's a good point, yes.
And see exactly if we've got balance there, if that's
right.
actually out of whack.
Yep, and that's a quick check. There's temperature gauges on the top here. Those are a little difficult to see, so they also put temperature gauges down here on the bottom on the outlet. So
what do
you've
these
got three
ones
of them
here represent?
That's a pressure gauge for the bundle.
Looks like inches and
yeah, this is actually
vacuum?
Yeah, when this condenses and it starts to pull into a vacuum, this will pull down a little bit, but it'll release immediately.
So for the most part, this gauge here is really acting as an advisory on the
how much steam
breaker.
and steam going in.
And steam
pressure. When this valve opens, you'll see your pressure go up 4, 5, 6 pounds maybe.
Yep.
As that valve closes and the steam condenses, you'll see this thing want to pull down below zero.
Yes.
You'll hear this thing just hiss. It'll pull in a little bit of air. If you were to put a regular gauge on here, it would probably break the needle because you'd have the pin and it would be hitting that pin.
Slammed.
So yeah, 30 to 30 gauge on these is perfect.
Let me ask you this.
How many, what's the GPM, gallons per minute, of one of these units?
I can get you that information based on the size of the valve and the steam pressure entering.
Yeah.
But just ballpark off the top of my head with a 3-inch valve, what's your steam pressure here? 50 pounds? Yeah. This thing could probably do 80 to 100 gallons a minute.
Okay. Because I'm running 3 units.
Yes.
Am I always going to have to run 3 units to maintain, or is this something that we're going to trial and error where, I mean, we start with 2?
Well, they do like to run, but if you find that you don't need all 3 to keep up with your demand, you can shut one down, run on 2, but you have to be very religious about rotating them.
No, yes,
I can kind of answer that a little bit, because the Whittingham, we tried that. What we did was we would shut one down, let one run, and then we'd alternate them. But we ended up getting into more problems. Yeah, because now it's settled. They're better off just running, even though they're not running at high capacity. They're better off just running. We tried that experiment and it didn't work.
Well, just from a lean, conservatory conscious effort, you know,
I understand.
We're using steam, and you know, if we're doing this on every one where we've got 3 units going balls out because They like to run.
Yeah. Well, they do.
They're not. They're not.
Well, that's
So
yeah.
they're just, I understand.
Yeah, that's the thing. If you, it's kind of like, you know, robbing Peter to pay Paul, I guess is a good way to put it, where if you shut down and you're running on 2, these are definitely going to work harder to keep up with the demand. But if you have all 3 on, they're going to work less. So it's, you know, I guess at that point it's apples and oranges.
The VFD,
I'm sorry?
they're having a VFD on.
Yeah. Right. Yep.
Yeah, we tried that before, and it didn't work.
Yeah.
I know, because I was the one doing it.
I'm sorry?
See that, the pigtail there? One there, one there. There's something that get in.
I'm guessing there's supposed to be gauges there. They have a gauge there.
Okay.
So I'm guessing that's just, that's your steam pressure line.
You know what
So-
they did, Jerry?
They're using that one just to show the pressure. They skimped on 2 gauges
Yeah.
No.
because it's all the same steam coming in.
Right. That's just the common